Here we are going to determine the future value for compound interest. Now, compound interest is interest that is not only applied to the principal, that's the initial amount, but also on any interest the principal is made over time. You can think of it as interest that keeps piling on. Now, initially we started out with the simple annual interest. I'm just going to write it here. That's our simple annual interest. I is equal to P, which is our principal, our initial amount, multiplied to the rate times the time, in which this amount of interest, this is the amount of interest that was applied to any particular principal. From here, we determine the future value, in which we want to know how much money there is overall. So that includes the principal that we first deposited plus the interest that it makes. Since interest is PRT, we can rewrite this as P plus PRT. We can then simplify this by factoring out a P, 1 plus RT. So our future value is P times 1 plus RT. Now this amount right here in the parentheses, this is the actual interest that's applied to the principal that will give us our future value. But this amount right here in the parentheses here is an annual amount. In other words, the interest will only be paid one time a year. However, almost all financial institutions or transactions occur several times within a year. So because of that, we are introduced to another variable called N, and I'm just going to put it right here. And N is the number of pay periods within a year. So rather than being paid a percentage once a year, this percentage is now evenly distributed or evenly divided throughout the year according to the number of pay periods. So then the future value for compound interest looks very similar to the future value for simple annual interest, except we have to account for the number of pay periods. So it looks like this. We have our future value that's equal to our principal, 1 plus, now the rate is not annual. It now has to be divided up according to the number of pay periods. So we divide it by N. So this is the percentage that's paid to the principal that gives us our future value. But this percentage here is applied several times throughout the year. It's the same amount applied several times throughout the year. How many times is it applied throughout the year? Well, it all depends upon the number of pay periods. So we just raise it to a power, which is the pay periods. Of course, this whole loan, the life of this whole loan, could go on for several years. So we just go ahead and we multiply it by T. So to be able to remember what this formula is we just kind of break it down from the very beginning, from simple interest, how simple interest can now account for our future value. And then, of course, to be able to take our annual future value with a series of compounds, we then have to introduce N, and we're at this point here. So for this problem, it says, suppose you deposit $2,400 into a savings account that earns 5.45% annual interest. What is the future value of the deposit, and how much interest will it earn after 5 years? And here's a term right here, compounded. And A, we have monthly, and B, we have weekly. So what I like to do is I like to go ahead and list whatever variables are already stated here within the problem. We have an initial deposit here, that's P. It's $2,400. We have an interest rate of 5.45%. We also have a time here, that's 5 years. Our compounds are stated according to a year. So there are 12 months in a year. So compounded monthly means N is going to equal to 12. That's 12 months out of the year. Weekly, there are 52 weeks in a year. So that means N would be 52. Now that I know all my variables here, I'm going to use my compound interest, my future value for compound interest. So I'm going to have future value. It's going to be equal to the principal. It's $2,400. 1 plus the rate, that's 0.0545, divided by the number of compounds for letter A, that's 12 compounds, that's monthly. How many times per year am I going to get this? Well, if it's monthly, I'm going to get it 12 times a year. Of course, the life of this loan goes on for 5 years. So I multiply that by 5. So then we have $2,400. And the first thing I'm going to do is I'm going to go ahead and I'm going to plug this in my calculator here. So I'm going to do 0.0545, and I'm going to divide that by 12. Remembering that we're going to go with 8 decimals, so this is 1 plus 0.0045 4167. This is then $2,400. 1 plus 0.004544167. That's 1.00454167. This right here, 12 times 5, that's 60. I'm going to raise it to the 60th power. I now take my 1.00454167, use my caret key right here, and raise it to the 60th power. So this is 2,400 times 1.3124. Again, 8 decimal places. 3378. So I'll take 2,400. 1.31243378. So the future value will be $3,149. And again, we're going to round to the nearest penny and 84 cents. So the idea is that you have $2,400. You deposit it in the bank that gives you a 5.45% annual interest rate. You're going to keep it in the bank for 5 years, but that interest is going to compound every month. At the end of 5 years, you'll have $3,149.84. The same idea for letter B, except for the number of compounds is 52, but we'll do the same thing. Our future value, that's going to be $2,400. 1 plus the rate, 0.0545, divided by the number of compounds, but this time it's 52. So this is the rate. How often are we going to get that rate throughout the year? We're going to get it 52 times every week throughout the year. How long is the life of the loan? Well, that's 5 years. We're going to get it 52 times a year for 5 years. So then this is $2,400. I'll do 0.0545 on our calculator. We'll divide that by 52. And again, using 8 decimals, that's going to be 1 plus 0.00104808. So this becomes $2,400. 1.00104808. 52 times 5. That's to the 260th power. I now take 1.00104808. Use my caret key. Raise that to the 260th power. So this is $2,400 times 1.31305712. I then take $2,400 and multiply that to 1.3130712. Close off that parenthesis. And that comes out to be $3,151, again rounding to the nearest penny, and 34 cents. So as you can see, depositing $2,400 that's compounded monthly gives you $3,149.84. Compounded weekly, there are more compounds. What does that mean? That means you're getting hit with this a portion of this 5.45% more often throughout the year. So logically, it would seem that you should get more money back, and which you do, not by much. It's about $1.50, but there it is. And we're done.